Hello. So this video we're going to talk about negative exponents. The first thing we're going to do is kind of discover the rule, like what happens when you have a negative exponent. So first thing I'm going to do is look at these 4 different expressions to simplify. All 5 to a power over 5 to a power. So I can reduce this because it's a quotient with the same base, so I can simplify these. So 5 to the third over 5 squared, I know is going to be 5 to the 3 minus 2, and I end up with just 5 to the first. Okay, now 5 to the third over 5 to the third, if I use the same rule, I get 5 to the 0, which anything to the 0 is just 1. Or you should realize anything divided by itself is just 1. So that's a good explanation as to why anything to the 0 is just 1. Because if you consider it to be like something divided by itself, it's always 1. And I get the same thing. Now on this one, if I use that same rule here, I would get 5, 3 minus 4, and I get 5 to the negative 1. Well, I know this is 5 times 5 times 5 over 5, 2, 3, 4. And if I reduce like we did in dividing monomials, I end up with 1/5. So 5 to the negative 1 should be equivalent to 1/5. Okay, sure. These should be equivalent based on the 2 different ways I simplified. Let's look at this next one. So if I use the rule here, 3 minus 5, I end up with negative 2. But if I expanded and simplified, 1, 2, 3, 4, 5, I would get a 1 over 5 to the second power. So according to these two things that are supposed to be equivalent, the 2 different ways I simplified, 5 to the negative 2 should be equal to 1 over 5 squared. So what I want you to notice here is that a negative exponent has nothing to do with the expression being positive or negative. It's actually a notation saying that your base is, if it's in the numerator, should be in the denominator, and vice versa. If it's in the denominator, should go to the numerator. So again, a negative exponent is just a notation. It doesn't mean the number's negative, because what we see here is 5 to the negative 2 is equivalent to 5 to the positive 2, but in the denominator. So let's turn that into a general rule. Okay, so here is our rule. If I have a base to a negative exponent, m, that's going to be equivalent to 1 over that same base to that exponent, but positive. So you lose the negative. It's like it becomes the reciprocal. Now, if you see a negative exponent in the denominator, I could do this a little more mathy way, where I make it the denominator in the denominator, but really what ends up happening is that it goes to the numerator. So this is the same as a to the positive m in the numerator. So a negative exponent, it's going to change where it was. If it was in the numerator, it will go to the denominator. If it's in the denominator, will go to the numerator. So again, a negative exponent is just notation. So it is just notation. It has no effect on the sign, aka whether that number is positive or negative. So just because I see 3 to the negative 2 doesn't mean that that's negative 9. That's an answer. If I see you write, for example, 1 that it equals negative 9, that's how I know you never really learned it or looked at the rule. Because that's kind of like a guess. You're like, oh, okay, I know 3 squared is 9. It says it's negative, but that's not right. This is equivalent to 1 over 3 squared. And if the exponent is small enough, we can just write that as like 1/9. You can raise it to that exponent. So something you have to be careful with, so with number 2, is what is being raised to that negative exponent. Because only the pieces that are being raised to the negative exponent should move. So that 4 is in the numerator. It has no reason to move, but that x is in the denominator with a negative exponent, so it's going to come up with the 4. And I'm going to end up with 4x to the positive 1. The denominator is no more, so my answer is just 4x. Now, of course, negative exponents will now be mixed in with our other rules. And you're going to have to practice to see which ones you like to do first. And I'm going to give you some suggestions which to do first. I'm going to, this is a positive 4, so it's not too hard to raise everything to the 4th power. So power to a power, I multiply. 2 times 4 is 8. Negative 3 times positive 4 is negative 12. So now you have to keep track of your positives and negatives. This q is being raised to a negative exponent, so it's going to go to the denominator. And there's my answer, p to the 8th over q to the 12th. I don't have any variables that match. I can't like simplify anything. That's all I can do. Okay, let's do the next one. Number 4, while you could do the same thing we did before, raising the 5 to a negative 3 and the y to the negative 3, I kind of don't suggest that. I find that when students raise numbers to negative exponents, they tend to get it wrong. What I like to do is treat it like rule number 1. I have something to the negative exponent, so it's going to end up in the denominator to the positive exponent. Those two things are equivalent. And then I just have to cube everything. So 5 to the 3rd power is 125, and y to the 3rd power is y to the 3rd power. Now if I did it in the different order, that would be 5 to the negative 3 times y to the negative 3. And you just have to realize 5 to the negative 3 and y to the negative 3, they're going to both go to the denominator and get cubed. Okay. I'm kind of zipping through these. In the next one, the only thing that needs to change is z to the negative 5. That needs to move up. And that alone. Because the 5 doesn't have a negative exponent. This 8 doesn't have a negative exponent either. So it's going to be 5 z to the 5th over 8. And that's my answer. Now, so I'm going to add another disclaimer up here. You have just notation has no effect on the sign. Like, notice how it's not becoming positive or negative. The only thing that would change is if you have like a negative number to an even power, make sure it becomes positive. Also note that you're not fully simplified if there are negative exponents. So think like how you can't leave a radical in the denominator, you can't leave a negative exponent in your answer. It's not considered done. So, example 6, the last thing, or like the only thing that's wrong with this or not simplified is this p to the negative 4th. I can't have negative exponents. So I know that's going to have to move, and only that. So that's going to become 1 over q to the 6th, p to the 4th. So make sure you have that 1 there. Okay, we're going to do one more on the next page. Okay, now this one is a quotient to a negative, and while I could raise everything to the negative 2 power, I know that everything's going to end up being raised to the negative 2 power. You know what? I'm going to make this problem a little different. I'm going to make this to the negative 3. So I edited that just so I can show you something. All right, so instead of raising everything to the negative 2, I would suggest when you see something like this to deal with the fact that everything's being raised to a negative. So the first thing I'm going to do is flip everything. I'm not going to change it. I'm just going to flip it and make this a positive. So now that's a positive 2. So let me repeat what I did. I have a quotient raised to a negative exponent. Everything's being raised to a negative. So I don't have to like pick and choose and figure out what's being raised to a negative and make sure that moves, whether numerator to denominator or denominator to numerator. Everything's being raised to a negative, so the first thing I'm going to do is flip everything. So it's the same thing as everything flipped raised to the positive 2. But notice how I didn't touch anything on the inside. This negative 3 is still a negative 3. Because what I was resolving was this negative 2 becoming a positive 2. So nothing else changed as far as like the exponents or the signs. So now I'm going to raise everything to the second power. 2 to the second power is 4. R to the negative 3 to the second power, power to a power, I multiply. And then 3 to the second power is 9. So you're raising everything to second power. Remember, for the numbers, you just do that like normal. For variables raised to exponents, you power to a power, you multiply the exponents to achieve that. Now, the last thing I have to do, because I can't leave this r to the negative 6, I can't leave a negative exponent, is just that r is going to move down because it's raised to a negative. Be sure to keep that 4 there. And that's my final answer. 4 over 9 times r to the positive 6. So again, make sure you have all positive exponents in your answer. So let me just summarize the rules we learned. So if you have x to the negative exponent, it's 1 over x to that positive exponent. If it's in your denominator, it needs to go up to your numerator. And we learned if you have anything as a quotient raised to a negative, it's the same thing as if you flip it. Oops. So y over x, that doesn't change to the positive. So those are like 3 kind of new rules if you want to add them to a note card. There you have it. And just remember, these rules exist with all the other ones. So when you're multiplying with the same base, when you're dividing with the same base, when you're raising power to a power, it's all going to work together. So this is going to take some practice as far as what's working for you. Yeah. Okay. Bye.